Lecture 3 is about quantitative or continuous traits. In the last lecture, Lecture 2, we reviewed Mendelian genetics, the genetics you primarily learned in your previous classes. Mendelian genetics makes a number of simplifications and assumptions that facilitate the analysis, but which apply to only a small number of human traits. One key simplification is that the trait is discrete and comes in two or a small number of types, like round versus wrinkled, or yellow versus green. Indeed, Mendel specifically chose these discrete traits in pea plants because it helped him figure out the genetics for these simpler cases. Of course, most traits are not discrete. They are continuous and quantitative. The definition of a quantitative trait is one in which the phenotype varies continuously over a range of values, instead of adopting 2 or 3 discrete values. There are numerous examples since the vast majority of human traits are quantitative. These include height, weight, blood pressure, heart disease risk, type 2 diabetes, mental illness, IQ, and many, many more. The distribution of these phenotypic values typically forms a normal distribution because the traits are determined by a number of independent genetic and environmental factors. The normal distribution, or bell curve, should be familiar to most of us. One classic example is the distribution of test scores from a population of students. The center of the distribution is represented by the mean or average. The width of the distribution is described by the standard deviation. Plus or minus 1 standard deviation typically encompasses approximately 68% of the distribution. Plus or minus 2 standard deviations typically encompasses approximately 95% of all values. The variance is another measure of the distribution width and is just the square of the standard deviation and is denoted sigma square, where sigma is the standard deviation. Assignment 3A is to calculate the mean, standard deviation, and variance of a distribution of values describing a quantitative trait, in this case, height. Let's go through this example together. So first we're going to go to our web browser right here and open up a new spreadsheet. So let's go to docs.google.com. And then under the menu, let's open up a spreadsheet. And you press the plus button at the bottom right corner to create a new spreadsheet. Let's first name it Assignment 3A Heights by, and then put down your name. Now in this first column, we're going to write down 10 or so heights of your friends and family in inches. And so let's all use the same unit of measure, and let's use inches. So I've already done this, and I'm just going to copy and paste these values that I have. Just fill them here in the first column. And now we're going to calculate the mean or average. And to do that, we go to a new cell and type equals and start typing average, A-V-E-R, and there we have average. It auto-completes, and we'll just click on it. And now we just highlight the values that we want to calculate the average of and press return. And there we go. The mean is 66.6 inches. Let's do the same for standard deviation. Equals STD, and there we have standard deviation. We'll click on it and then highlight the values and press return. It's the standard deviation. And finally the variance. Type equal VAR, there's variance, highlight the values, return. You can see that the variance is just the square of the standard deviation. And let's label our answers: mean, standard deviation, and variance. The final thing for the assignment is to share that with me. So click the share button and enter my email address, and just you can use my Gmail, and then can view, and then send it. And there. And that's done. And I'll take everybody's spreadsheet and compile all the heights together, and then we can look at the overall distribution. And one would predict that distribution will look very similar to a normal distribution. Okay. The final definition for today's lecture is that of a threshold trait. A threshold trait is one in which you create discrete phenotypic classes from a continuous range of values by establishing thresholds or bounds for each class. One example is blood pressures. Medically speaking, high blood pressure is defined as a systolic over diastolic pressure greater than 140/90. That's high blood pressure. Normal blood pressure is between 140/90 and 90/60. And then low blood pressure is defined as less than 90/60. Another example of a threshold trait, and here we're using the term trait loosely, are grades. From the normal distribution of test scores, a teacher can define the bounds for A, B, C, and so forth. And these typically represent one or two standard deviations above or below the mean. For example, one standard deviation above the mean will be a B, and two standard deviations above the mean will be an A. As we learned at the end of last lecture, a complex trait, and the vast majority of human traits are complex, is non-Mendelian, and in particular it violates two of Mendel's assumptions. First, and we'll talk more about this in lecture 4 on Tuesday, a complex trait is determined by multiple genetic and environmental factors, rather than a single gene. In other words, it is multifactorial. Second, complex traits are quantitative traits rather than discrete traits. And today we learned about quantitative traits. So for the last part of today's lecture, we will create the Google document for your term paper. So let's go back to the browser. And under File, we'll create a new document. And let's name the document MCDB194HG-S15 and term paper by, and then write down your name. And then share that with me. Go to the share button in the top right corner and just type my Gmail address. And then make sure I can comment on it. And then send that. And now we can start to fill it in. And so the first thing I want you to do is copy and paste the 17 questions from the term paper instructions into the document. And so we can go and look at the instructions. And here are 17 questions. Let's just go ahead and just copy and paste them all in. I use the Command C or Control C. And then I can go to Edit and Paste. And here are all the 17 questions. And the formatting was a little bit disrupted, and so we can go ahead and clean them up. So fantastic. We are ready to go and can start filling in the answers to the questions and, and start filling in our term paper. Assignment 3B is to answer this first question. Pick a human complex trait and provide background information on the trait. And again, these are just suggested length values. There's no real maximum or minimum, and I say 2 paragraphs. Each student will choose a different trait. So I'm going to compile all the traits that you all pick into one spreadsheet so you can see what traits have been already chosen. And so this is in a spreadsheet that I'll share with you. And the name is Complex Traits for this class. And here are all your names. And so once you've picked your complex trait, you can just go ahead and type it in. And it's going to be first come, first serve. Later on, you can go ahead and change your selection, but then you're going to have to rewrite any sections of the term paper that you've already completed. And make sure if you do change your complex trait that you update the spreadsheet so that we have no duplicates. If you're looking for suggestions for a complex trait to pick, I have a spreadsheet that I'll share with you with a list of the complex traits. And again, this is a small subset, so feel free to pick a complex trait that's not on the list. And so once you've picked your trait, you're ready to go back here and start filling in the information about your trait. And basically I want some background information about 2 paragraphs worth. And make sure you cite your sources. In summary, in this lecture today, we have learned about quantitative or continuous traits in which the phenotype varies over a range of values rather than 2 or a few discrete types. Typically, the phenotypic values follow a normal distribution whose center is described by its mean or average and whose width is represented by the standard deviation sigma or the variance sigma squared. A threshold trait occurs when you form phenotypic classes defined by thresholds or bounds on the continuous phenotypic values. The example that we provided was high, normal, and low blood pressure. Finally, we have created our term paper document and started it by picking a complex trait and writing a couple of background paragraphs.